But today is
Yeah.
module three.
Three.
Yes, we are still on identifying various type of fingerprint. Identifying various type of fingerprint. Um, Last week we talked much about how to uh, identify fingerprint using the data and also the core. Now we want to continue today by talking about the ridge count. Ridge counting is using the ridges or the lines, those ridges and the lines or the lines between the data and the core. When you make a straight line between the data and the core, and the ridges that fall between them is known as ridge counting. That is, we want to know the number of ridges that exist between the data and the core. So when you draw a straight line between where you put your core and the data, that will give us the ridge counting. And if another person, another examiner do the same thing, they are going to get the same thing, get the same result. So ridge counting is highly essential. Knowing ridge counting, the core, the data. So those are some of the things that we use in identifying the print. Just as we said last week, you may have the first set of classification, like the using the loop, the first one arch, loop, or the wall. But you still need to go further, because at times you may have in two fingerprint that you want to compare. Both of them may belong to the same family or the same group, maybe arch. So you still need to go further. So by doing so, what you need here, you can locate the data where you can locate the core and the ridges, the numbers of ridges that we call ridge counting, the number of ridges between them. Then later we'll talk about other means. But if you're able to locate those three things, the job will be so easy for you. And there are some characteristics that we call minute. These are the minute of the fingerprint. The minute of the fingerprint that shows their various features, such as the ridge endings, bifurcation, islands, short ridges, and so on and so forth. Now let's look at my board and my the screen. Please look at the screen. Can you see the screen? Okay. Now these are
Yes.
some of the things, some of the features that you see inside every fingerprint. Maybe loop, maybe arch, maybe wall. These are the things that you'll be seeing there, the features, the characteristics that you see there. We call them minute. Minute. That is, they are the minute of the print. They are those things, those characteristics that you see there that differentiate one fingerprint from another. That's the highest level of differentiation. The first one is grouping them. Then the second one is using the core, the data, and the ridges. Then the last one, which is the highest one, is using the characteristics, the minute. And now let me mention some of them. We have a bifurcation. Bifurcation is where you have a ridge that fork into two or split into two, as when you have a road that diverge into two. So one single line or one single ridge splitting into two, we call it bifurcation. Then at times it may be into three. Then in that place we call it a trifurcation. That is, you have let me choose a pointer. Yes, can you see the screen? Can you see my pointer, my indicator here? Hello, sir. Hello, doctor. Okay,
Yeah,
can
I'm
you see
listening, sir.
my
Yes, I'm
indicator?
listening.
This blue.
With the green, your green detector showing the one that's pointing
Yes,
at it,
yes.
that two-edge
So
thing down.
this is known as
Okay,
bifurcation.
sir.
That is a single ridge
Okay, sir.
diverging into two or splitting into two. That is bifurcation from the word bifurcation. Then we have from the word bi and forcate, that is splitting into two. Then at times it may be three, it may split into three. Then in that case we call it trifurcation. Now, but at times you may have double bifurcation on the same line. You have maybe here you have it split into two, and this one is going, and you have it also split into two. In that case, we call it double bifurcation. Now you have okay, this is trifurcation. Then you have a spur. That is when you have a straight line, and it seems as if another line join it at an angle that is more or less than 45. So you call it spur. Then you have a island ridge. That is when you have a ridge that is surrounded by empty space, just standing on its own. That is island ridge. Then you have dots. Now, before I go to that one, this is bridge. When you have a bridge that is going like this, another one branches from it and join another line that is going parallel to it. So we call that one bridge. That is a uh, a ridge is bridging two ridges. A ridge is bridging two ridges, so we call that one a bridge. Now we have also ridge ending. That is where you have an approach ridge stoppage. The ridge is moving, but get to a place, the thing just stop like that. That is ridge ending. Now let's move further. Look at this. This is a print. On this print, we have some characteristics that we'll be try to identify. Look at this one. This is ridge ending. This ridge started from this place and now move over and up to this place. Then it stopped moving. So it's no more going further. That is ridge ending. Then look at this one. This ridge from here, it moves up. Then on getting to this place, it's splitted into two. That is bifurcation. That is bifurcation. Then you have another ridge endings inside here. Then you have enclosure. Enclosure is when you have a ridge that split into two and also join at the same time, leaving a space between itself, enclosing just a space. That is enclosure. And then you have a dot, ridge dot. This is ridge dot that is just like a circle. Then you have a yes. So there are many like that, and so on and so forth. So this point can help us, you can help us to identify two prints. There are cases where you won't have the print that is brought to you may not be a complete print. That is, a part of it has been mutilated. So in that case, something like your data, the core may not be visible there, you may not be able to see it there, or probably during the time they were taking the lifting the print from the crime scene, it is possible that that part of data and core and the read count between them has been is blurry, so you can't see very well. But using this all other features, you can easily identify, do your comparison and make identification or otherwise. So now, if you have a print where you can see all these things clearly, then it's good as having a whole print. Let's move ahead. Last week we talked much about loop. So let's conclude that one. There are something you can use to say this is a loop or not, and we refer to that one as essentials of a loop. Essentials of a loop. Every loop must have a sufficient recurve. That is, there must be at least some of the recurve that will move and move inside the print and go back the same side. Then there must be a data for a loop, for any fingerprint to be qualified as a loop. It must have a sufficient recurve, a data, and a ridge count across a loop ridge. Across a loop ridge. A sufficient recurve, a data, and a ridge count. So we are coming back to that ridge count later. So in all the print that you'll be encountering, loop is about 65% of all of them. Most of fingerprint will belong to loops. They belong to loops because it's about 65% of all the fingerprint that will be encountering. Now, let's move further to ridge count. Now, ridge counting, when you, after identifying your data, where you have your data, assuming this is our data here for this figure, this is our data. Now, to get the ridge counting, what we do is that we count the numbers of ridges between the data and the core. The numbers of ridges between the data and the core. Now, this figure, this is the data. Then we start counting from here. 1, 2, 3. So our ridge count here is 3. Now look at this, the first figure here. In the first figure, inside the inner recurve, we have a spike. So this spike, we start counting this on this spike is our core. On this spike is our core. So we start counting from this one, from this line. This is 1, 2, 1, 2. So we have two counts here. So our count starts from this line, this ridge after the data. So we count 1, 2. So we have two ridge counting here. Now this one, after this one, we start counting here. This one is 1, 2, 3, because our core is on this side of the innermost recurve. So that's how you get our ridge counting. Now, assuming you have something like this, So what we need to do is, after this ridge dot is our data here. This ridge dot is our data. So we start counting from here. We count 1, 2, 3. Then our core is this one, because anytime you have two spikes inside the innermost recurve, our core will be the one that is far away from the data. So you count it 1, 2, 3. So this is our 3 is our ridge counting here. So if you have another print that has the same ridge counting, the same, and the core is in the same place. Then also the data is also in the same place. You can be assured that the print are the same. That means you have a match between the two. You have a match. So let's move further. Then when you are making your ridge canting, at times you may see on the print, you may see some fainted lines, lines like this. Those fainted lines may be as a result of the real ridge, the main ridge, splitting or fraying away. So in that kind of situation, you don't count this faint line. You don't count it as a ridge. You count the thick one. So the thick one will be counted. So you just leave the fainted one. Now look at this. So if you want to make our ridge counting now, we start from this place. This is our data. This is our data. So now we start from here. 1, 2, 3, 4, 5, 6, 7. Because our core will be here. So that's our ridge counting is 7. So the same thing here. So we start. This is our innermost, the two innermost, our type line. This is our type line. This one, this line 1 and line 2. These two lines. So moving to this place. At the place of divergence, here is our data. This is our data. This ridge is our data. So we start counting from this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, this is 10 because there's a spike here. This is spike touching this line. So do you understand me, sir?
Yeah, I do.
Okay, so you still get
Yeah, I
inside
do.
the manual. I mean inside the handout. So now, so that is how to do the ridge counting. And if you look at the screen, you can see we have radial and ulnar loop. The radial loop will be to a side, while the ulnar loop will be to the other side. We have on our arm, we have two bones. One is a radial and the other one is ulnar on our forearm. So the term radial and ulnar are derived from the radius, that radius bone and ulnar bones of the forearm. So loops which flow in the direction of the ulnar bone, the loop that flow in the direction of the ulnar bone towards little finger are called ulnar loops, and those which flow in the direction of the radial bone are called radial loops. But whether it is radial loop or ulnar loop, the way you do the ridge counting are the same. They are the same. Now, also, you have a plain arch. We talk about plain arch the other time, but let us explain further some things that you may not talk about. Now, we said we have plain arch. In plain arches, the ridges enter one side of the impression and flow or tend to flow out the other side with a rise or wave in the center. Look at it. Look at this at the screen with a rise or wave at the center. That is a plain arch. The plain arch is the most simple of all the fingerprint patterns. You can easily recognize them. As soon as you see them like this, you can see this is a plane. This is a plain arch. This is an arch and a plain arch. And it's easily distinguished. So if you look at this figure and this figure and the other one, this figure 107 on the screen, and that is and that of 108, you can see that they are a sample of plain arch. There are various formation, but those things that we talk about, the ridge characteristics that we talk about, that is the bifurcation, ridge ending, and so on and so forth, they are all present in plain arch also. But the one thing we should take note is that even though those things are present, they still move in direction of the flow. They move in the direction of the flow. If you see ridge ending there, it will move in the direction of the flow. Bifurcation, dot, island, and so on and so forth, they still move in the direction of the general contour. So all of them, maybe dots, maybe bifurcation, and so on and so forth, they enter on one side and make a wave or a rise or wave in the center and flow or tend to flow out the other side. That is the characteristics of all of them. Then we have a tented arch. Tented arch. Sorry, okay, this it. Now, in this one, there are types. This one also has different formations. In the tented arch, most of the ridges enter upon one side of the impression, as you look at it, and flow or bend to flow, or tend to flow out upon the other side, as in the plain arch, just like the plain arch. But the ridge or ridges at the center do not. Look at it. Look at this one. You can see that you have something, a ridge that is flowing up and getting to this place, it stopped, didn't flow to the other side. So the ridges, it may be one or two or three at the center, will just rise. So there are three types of tented arches, about three of them. We have the type in which ridges at the center form a definite angle, like 90 degree or less. Like 90 degree or less. The ridge at the center just stands straight, almost straight, or less, 90 degree or less angle at the center. That is one. Then you have another one, the type in which one or more ridges at the center form an upthrust. An upthrust is an ending or ridge ending of any length rising at a sufficient degree from the horizontal. At times, the angle may be like a 45. Look at this one, or more or less 45 degree. So, and the third one is the one that is approaching, that is almost like a loop, more or less like a loop. So, those are the three types that you have. What is the time? So now, tented arches
4:34.
and some form of the loop may look confusing, but it should be remembered that the mere converging of two ridges does not form a loop. Does not form a delta. without which can be loop, which can be no loop. When there's no, you can't see a loop without the data. So even though you have an hash that look like a loop, but when there's no data there, then you cannot call it a loop. So there are many patterns which at first sight resemble plain hash, but which on close inspection are found to be loops, as where one loop region will be found. Now, what we need to do is to look closely at some features inside the loop. For example, no hash will have ridge, they will not have ridge, so and they will not have core. Those two things are not common to are not a part of the features of any arch, but they are features of loop. Even though they may look alike, but the time you look at it and you are able to locate data and core there, then you know that this one is not an arch. So we said the other time that every loop must have a sufficient recurve, must have a data, and also must have a ridge count across a looping ridge. So those are the characteristics of any loop. Without that, you cannot say any print as a loop. Now, I want us to stop here today, and the rest of it will be
Okay.
done in the next class. That is going to be the word. Word is something that is totally different from others, and I don't want us to be to confuse things. So you have to do that on separate. So, and that's going to, the next class is going to be the last class over this identifying fingerprint type before we go to the next thing. And that one is lifting fingerprint from surfaces. That is after the next class. Then, yes, sir. After that one,
Thank
then
you,
we
sir.
go to how to make comparison. So all these things will help us in comparing two fingerprints. So we are stopping here today. I will send all the lecture notes and the other materials. So until Saturday, sir.
Thank you, sir.
Yes, sir.
Thank you, sir.
I'm grateful.
Thank you, sir. Yes, sir.
I'm grateful.